Okay, the next section in the paper 6 will be a modelling question. Okay, now let me explain what we mean by modelling. Okay, modelling means, in a mathematical sense, means come up with a mathematical formula, to basically describe a real life situation. So if I just give you a very, very, very simple mathematical model, okay, but perhaps you want to build a rectangular fence. Okay, you want to build a rectangular fence, and you want the width of it to be x, and you want the length of it to be 4 more than x. Okay, then you want to find the area. You want to model the area of this rectangle. Well, we model the area of the rectangle simply by saying that the area as a function of x is equal to x times x plus 4. That is a model, because what this model does is it tells me every single area for every single value of x that we can think of. Okay? So this is your model. It's your function. Your function is your model. It's just modelling something that is in the real world. Okay? So part B of your paper 6 will always be about mathematical modelling. And just like part A, we'll start off very easy, and it will have some pretty nasty questions in there as well. Okay? What you need to do is, when you get a difficult question, maybe you give up on it. That's fine, but just because you give up on part A doesn't mean you can't do part B. So just bear that in mind, okay? You don't give up on the whole paper just because you give up on one part of it. So let me show you an example, okay? So got this question. Make sure you read the whole thing, okay? So you could do that. I'm not going to read it because I'd just be wasting time. But you should read the whole question. So this diagram models the situation, the real life situation that you've got above, okay? It says use the right angled triangle ADB to show that the length AB is root 13. So right angled triangle ADB is this triangle here. We want to show that AB is root 13. Well, that should be pretty easy. Just a bit of Pythagoras' theorem. AB squared is equal to 3 squared plus 2 squared, which is equal to 9, plus 4, which is equal to 13. So then AB is root 13. Can't really get anything easier than that. Okay, now we're asked to write down the value of sine ABD. Sine ABD, that's the angle ABD. ABD, that's this angle here. Okay, that's opposite over the hypotenuse. There we go, there's sine of angle ABD. Let's just write that down under there. You'll likely need answers from previous parts of the question to help you with next parts of the question. So just bear that in mind. That's another little technique. Some of the answers build upon each other. So the answer to part A2, you're probably going to need it in a little bit. Okay. Right, now show that the length AC, so AC is this one, is equal to root 10. Well, again, bit of Pythagoras. AC squared equals 1 squared plus 3 squared equals 1 plus 9 equals 10. AC equals root 10. Okay, so that's root 13 there, root 10 there. Okay, part 1 is very, very, very easy. You shouldn't be getting any of them wrong. So the key to being successful in paper 6 is just getting the easy stuff right and giving yourself time to then focus on the difficult. Okay, so here is where it begins to get a little bit more difficult. Okay, Regiomontanus wrote, it doesn't really matter what his name is, in triangle ABC, the sine rule. Okay, so he wrote the sine rule. Show that sine BAC is equal to 3 over root 130. Right, I'm just going to draw that triangle again, just so that I've got it here. Look like this. 1, 1. This was 3. So this was root 10. This was root 13. And this angle, this angle here, what we knew is that the sine of that angle was equal to 3 over root 13. Okay, that's angle BAC. So I think it was A, B, C, D. Okay, ABD rather. So what we want to know is what is the sine of angle BAC. BAC, that is this one here. Let's just call that alpha. Let's call that one alpha. Just, you know, why not? We can call it whatever we like. Okay? Then we can say that sine alpha over 1 is equal to sine theta over root 10. Okay, sine theta over root 10. That's just applying the sine rule, which we use for non-right angled triangles, which ABC is. Okay, so we can now say that sine alpha is equal to, well, if I times both sides by 1, that won't be affected. Sine theta over root 10. Now this sine theta is the sine of angle ABD, which we already worked out. Okay, we already worked out that that was 3 over root 13 over root 10. Now this is the killer for you guys, is fractions. You've got to remember the rules of fractions. So fraction divided by, root 13, divided by another fraction. Okay, so we flip and multiply. So 3 over root 13 times root 10. I'm an idiot. Got this the wrong way around. That's divided by root 10 over 1, not 1 over root 10. So it will become, it's getting ahead of myself, it will become 1 over root 10 when you flip it. And so that is equal to 3 over root 13 root 10. And now you've got your rules of surds come into play. So it's 3 over root 130. Okay, so we have shown that that is the right answer. Now, here is another little technique for you to consider. This question says, show that sine BAC is 3 over root 130. So, firstly, that means you know what the answer is. You're just aiming for the answer. You need to show the steps to arrive at that answer, that's all. But you know what it is. Which also means that if you can't do that question, well, you've still got that answer to help you with the next parts of the question. Okay? So use that fact. Maybe you couldn't do part C. Doesn't mean you can't go and do some of the questions in question 2 that are coming up. Okay? So please, please, please don't give up on a question just because there's one little part that you can't do. Okay? Just with that keyword show means you already know what the answer is. You just have to aim for it. Okay? You just have to show how we got it. Okay. Using the method in question 1, find sine BAC when AD